Hey everyone, this is Group 20. Today we'll be going over our group presentation for SYS 4010. Our project that we made was a global storage service. My name is Hassan. My partners Abir and Ryan. They'll introduce themselves as the video progresses on. So our overall objective for the project was to create an application that acts as a temporary global storage service, meaning that data would be sent out and it'd be stored on the cloud for some allocated amount of time before access to it is expired. So it's kind of similar to a caching system in a sense, as data is held for a short period. And in our view, we see applications using our system to store and retrieve data. Now, the type of data that would be used is most likely short term, like session tokens, for instance. And in our application, multiple entities that share the same access keys can access the same set of data. And as mentioned before, the data has a specified TTL, time to live, meaning after a certain period, it's expired and access to it is not possible. So now we're moving on to contributions, what we were able to accomplish. So we were able to get to implement our system, and it comes packaged as an easy plugin tool, which allows both get and set functionality. The storage system differs from a traditional database since there's no specific structure to that database. Many users of the service may choose to input whatever type of data that they desire. So it's basically using the set operation, and the return of that operation will be a key. Now, this key that's returned, it gives access to the object. It's up to the user on how they want to store those keys, be it in a file or some specific data structure. From there, the keys can be used in the get operation to retrieve those stored data. So now we're just going to move on to how this type of service is actually helpful in the development cycle. This application isn't really suited for critical data, we realize. Rather, its purpose is for short-term data, like passing around tokens. And there's many scenarios where temporary storage is required for objects of different structures and sizes. Using our software would remove the need to handle inconsistent data sizes and structures that are only really required for a limited time. For example, there may be a limit to the size of a response object on your server, and this is where our service might be useful, as one can simply store that object on our platform, and instead of returning the response, they can send out the generated reference key instead, which simplifies this solution. Overall, our service can be seen as an API, allowing for post and get, uh, allowing users to post and get data for a limited time. And the keys enable multiple entities to access the data with the least amount of configuration required. So the service in itself is a simple and quick solution for temporary storage without really having to set up any prior infrastructure.
Now, we're going to talk about the tools we used to build our product. We used Lambda functions to build a serverless platform that creates, manages, and deletes all of our data. Lambda functions are independent functions that run on the cloud and are fully scalable and self-managed. All you need to do is provide the logic for the function and AWS handles the rest. We have two Lambda functions that act as the setter and getter methods for your personal global storage. Each function costs about 20 cents per million requests, making this a very affordable solution. To allow public access to these functions, we had to leverage something called API Gateway provided by AWS. API Gateway provides a fully managed REST API access to services in the AWS ecosystem. The networking, routing, and optimization is all handled by AWS for a cheap price of $300 per 300 million requests. To store all the unstructured user data, we needed a NoSQL database. DynamoDB storage provided by AWS is a fully scalable NoSQL database that provides efficient partitioning and sorting for quick and easy access. This also comes at an affordable price of $1.25 for a million write and 25 cents for a million read requests. The overall cost for a million operations using our system is around $1.70, and we can easily sell this solution for a premium on top of this. Lastly, we manage all of these resources using AWS Amplify, a cloud framework to build simple and efficient backends for mobile and web applications. Amplify provides easy setup and integration for a wide variety of AWS resources. Amplify is also an open source framework that is actually supported by AWS and recommended by their developers. Using our cloud resources, we were effectively able to create a set and get method for global data storage. We were able to create a library that abstracts all our cloud resources and handles all API calls and data management in the background. The entire system is fully scalable at very affordable prices. The user only needs to import the library, provide the API key which they have purchased, and use the set and get methods to retrieve their data. The data is secured with their API key and is inaccessible by other users. The library uses an HTTPS protocol to communicate with our backend to ensure the reliability and the security of the user's information. Our solution also provides a very simple yet effective design to deliver the service to the user. We provide a get method that takes in an ID as a parameter and returns the corresponding data. We also provide a set method that takes in the data you want to store and an optional ID and stores your data and generates an ID if needed. You can import the libraries on multiple applications and effectively share data between them very easily using our service.
Hey guys, I'm Ryan. For those of you who are interested in our project, a few areas to look into further would definitely be AWS Amplify. As mentioned, it's a CLI tool to help you with configuring your cloud resources. So definitely Amplify is a major one. There is support for both iOS and Android separately. However, majority of the support from what I've seen is for JavaScript and React Native. Also, we have DynamoDB, Lambda, and API Gateway. So those are all our AWS resources individually. However, with Amplify, we were able to configure those things in one area through the CLI, and its integration was all handled for us. And what I mean by that is when configuring a certain resource with Amplify, it allows you to add, let's say, triggers. So when adding a storage resource, it would ask you, would you like to add any Lambda triggers? And you can simply say yes and go from there. So in terms of what worked, we did get the general idea of a global storage working. Given a key, users could use the set and get operations. However, there were some limitations to what we've implemented. So for one, because we've offloaded all the storage onto DynamoDB, this restricts the types of data that we accept. So in the scenario where users want to store files, audio, anything like that, we would not be able to accept that. However, anything in the JSON format is valid. So with that in mind, a few things that we would like to change or add to our system would be the option for users to set a time to live on their data. Also create a payment system so users would be able to track what they're using and for how long. And with that comes a dashboard, so analytics to track their usage, request traffic, etc. And of course, automating the public and private key generation, because as of now, we have to manually do that and provide the users the key, which gives them access to our operations, which are the set and get method.
This is a quick demo of our global storage library. The library is set up as an importable class that takes in an API key and provides a set and get method. The set method takes in data, and you may provide an ID to overwrite any existing data associated with that ID. Otherwise, an ID will be generated and returned to you for your reference. The get method takes in an ID and returns any previously stored data associated with the ID. If no data was stored, it will return an empty object. To start off, we need to import the library and instantiate a singleton class with the API key as an argument. The API key will need to be purchased from us and will be used as the authentication and security system to ensure you are only able to access data based on the key you provide. We can then call the set function. I will not provide an ID and let the system generate an ID for us. We will then assign the ID returned to a variable and print it out. As you can see, this is the ID. Now, in a completely separate application, I want to access the data I just stored. To do so, I just need to use the get function and pass in the ID I saved previously. I can then print out the data as follows. As you can see, the first two steps are essentially the same, and then the get function just takes in an ID, and we console.log the data that we get. And the initial object that we stored over here, we can see over here as well. As you can see, it is a very simple tool that helps provide synchronicity between independent applications with very minimal overhead. And we can also take a look at our database, currently empty. And as I inserted it previously, if I refresh, I will see the data stored as is. So as you can see, the API key stored with the data as well as the ID, and then the data itself. Thank you.